So today's experiment is based on linear convolution of the given sequences. Finding the linear convolution, finding the convolution of the given two sequences. So first sequence is x of n. So x of n is equal to 1 to 1 minus 1 and h of n is equal to 1 to 1. So any sequences we can take to find the convolution of the given two sequences. So here two sequences are, first sequence is x of n 1 to 1 minus 1 and second sequence is h of n, that is 1 to 1. Now, so in the convolution we have a procedure, right? So first, what is the convolution? Convolution is nothing but finding the relation of one sequence upon the second sequence. So in the same way, first write down the given two sequences. Given x of n is equal to 1 to 1 minus 1 and h of n is equals to 1 to 1. Now, so n1 is equal to, so while representing the input sequences, the arrow marks are very important in terms of sequence method. So give the arrow mark for x of n as a first one for 1 as well as for h of n also as a 1. Okay. So n1 is equals to length of first sequence. So how many samples we have? We have 4 samples. Now same, n2 is equal to length of second sequence. So length means how many samples we have, like how many values we have. So here we have 4 values. For second sequence we have 3 values. Now for finding the L is equal to total output sequence length. The total output sequence length is equals to, so we have a formula in terms of linear convolution which is n1 plus n2 minus 1. Now substitute n1 value, n2 value and minus 1. So 4 plus 3 minus 1, that therefore L is equal to 7. 7 minus 1, 6. L is equal to 6. So this is the total length of the output sequence. So firstly, finding the linear convolution, we have first pre-processing steps are finding the L value based on n1 plus n2 minus 1 and second pre-processing step is finding the starting index for output sequence. So these two values, that is length of the output sequence as well as the starting index value, all are depends on two input sequences, the given two input sequences. So similarly, the next step is we have to find out n. So n is equals to small n1 plus small n2. So n1 is starting index for first sequence and n2 is starting index for second sequence. n1 and n2. So let us consider n is equal to, small n is equal to index, the starting index for first sequence. If you are observing the x of n is 1 to 1 minus 1. So the starting value is n is equal to 0. Suppose instead of having arrow mark here, suppose if I have an arrow mark here, right? So then n is minus 2, minus 1, n is equal to 0. Then what is the starting index? Minus 2 is the starting index. But here in this case, we have the n value, starting of n value is, that is 0. N is equal to 0. Then the n1 is equal to the starting index value for the first sequence. It is equal to 0. Similarly, we have n2 is equal to, again, the starting index point for second sequence. Again, if you are identifying h of n, so this h of n is having 1, 2, 1. So again, it is starting from n is equal to 0. So therefore, n2 also starting at 0 point. So therefore, n is equal to, small n is equal to the starting index for output sequence. Starting index for output sequence. Therefore, the formula is n1 plus n2, 0 plus 0. Therefore, the n value is starting with 0. So, in the formula linear convolution formula, we have the output sequence y of n is equal to x of n convolution with h of n. Now, summation of k is equal to minus infinity to plus infinity, x of k, h of n minus k. So this is overall formula for getting a linear convolution. So to get the same, first of all we have represented the input sequence as a discrete time signal, that is a train of impulses, summation of x of k with the shifted impulse response. Thereafter we have applied to the linear time invariant system. So there we got this formula, right? So based on the formula, we have y of n is equal to summation of k is equal to minus infinity to plus infinity, x of k, h of n minus k. So here n, so this n we have already determined, that is n1 plus n2, that is equal to 0. Now to solve this problem, we have three types of methods. One is graphical method, second one is tabular method, and third one is sequence method. So here I will explain about three methods we will explain. Thereafter we will write a MATLAB program. Now first, graphical method. In the graphical method, x of n and h of n has to be represented graphically. Now depending upon that, see, in the formula I have x of k and h of k. So the very first, whether in terms of graphical method or tabular method, is change of index. Okay, so first, change of index change. So directly in the given sequence we have x of n, that is 1 to 1 minus 1, and h of n, that is 1 to 1. Now change the index n by k, then draw it graphically. So first I am drawing a graph of x of k and x axis is k, h of k with x axis is k. Now if you are identifying x of n, so this x of n will have 1 to 1 minus 1, that is for n is equal to 0 I have an amplitude of 1, then n is equal, that is k is equal to 1, I have an amplitude of 2. So basically if it is x of n, the x-axis is n. If it is x of k, now we are changing the index n by k, right? So the sequence is 1 to 1 minus 1. So here also I have 1, and at 3 I have minus 1. So this is a graphical representation for first sequence. Now next, the graphical representation for x of k is, it has n is equal to 0, n is equal to 1, and n is equal to 3. 2, right? So first it is 1, then it is 2, again it is 1. So n is equal to 0, 1, 2, or k is equal to 0, 1 and 2. So this is the first step in the graphical representation or a tabular representation. Anyway, we have to change because in the formula we have k, x of k, h of k. Now the next one is, instead of h of k we have h of n minus k. So first of all we have to find out h of minus k, then we have to find out h of n minus k. So that is folding or time reversal we can call. Time reversal. In the time reversal or folding, we have to obtain h of minus k. So this is the next step in the linear convolution. Okay, next, folding the sequence in order to obtain h of minus k. So general h of k is having at n is equal to 0, 1 and 2. So this is 1, 2, 1. Now x-axis is k. Now to get the folding sequence, so what I used to do is, I will make 0 as a reference and I will fold the sequence into half. So whenever I used to fold the sequence, then 0, that is the reference is same as it is, then this is left samples. So these samples will be shifted to right. Okay. So I have at n is equal to 1, I have an amplitude of 2. Now what is the amplitude at n is equal to minus 1? That is 0. Now 0 will be shifted to 1. And 2 will be shifted to minus 2, or minus 2 value will be shifted to plus 2. The same value, that is, now if I fold the sequence, minus 1 value will be transferred to plus 1 and minus 2 value will be transferred to plus 2. Similarly vice versa, plus 2 value will be transferred to minus 2. Then at 1 I have 2, now this 2 value will be shifted to minus 1 value, that is 2. Now what is the value at 1? That is 0. Now again same, this 2 and k is equal to 2 value will be shifted to k equal to minus 2. Then what is the value at 2 value? That is 0. Now this is h of minus k and the x-axis is k. So this is how we have to shift the sequences. Okay, so this is called folding. Now using the formula, I have h of n minus k. So already I have determined h of minus k. Now I need to determine h of n minus k. So n value already I have determined, that is n is equal to 0. So depending upon the n value, if n is equal to positive, then h of minus k will be shifted to right side. If n is equal to negative, then h of minus k will be shifted to left side. By how many samples? By how many indexes? By what is the n value? Suppose n is equal to plus 2. If I got, but here in this case I got 0. So n is equal to positive, then h of minus k will be shifted to right side by how many index values? By 2 index values. If n is equal to minus 1, then h of minus k, that is, it has to be shifted to left side by only 1 value. The sequence, n value is 0, therefore we have to start the sequence from the positive case. Now the starting n value is 0, so therefore if you are substituting in y of n, that is k is equal to minus infinity to plus infinity, x of k, h of 0 minus k, that is h of minus k. Now we have we have to draw the sequences. That is, first input is x of k, 0, 1, 2, 3. Index is k, so this is x of k. So 1, 2, 1, minus 1. Now I have to multiply this sequence with h of minus k because it is multiplication of. So next step is multiplication. Then after multiplication, we used to make a summation. So these are the 5 steps we have to follow. So very first step is changing the index. Second step is folding the h of minus k. Whether you can go with h of n minus k or you can go with x of n minus k. Both are, you will get the same answer. Whether you are shifting the impulse response or you are shifting the input, then you will get the same answer. Then the third step is shifting based on n value either to the left side or right side. The next value is multiplication and then summation, because in our formula we have a summation is equal to x of k multiplied with shifted impulse. Now h of minus k is at 0 I have 1, then minus 1, minus 2. So that is, here it is 2, here it is 1. Now if I multiply these two sequences, then I will get y of 0. So n value, starting n value is 0. Then summation of k is equal to, here my starting value is minus 2 and here the ending value is 3. X of k into h of minus k. Now if I see the combinations of these two sequences, so I have only one combination, that is at k is equal to 0. At k is equal to 0 I have a common sequence. So therefore if I multiply, then I will get the answer y of 0 is equals to 1. So this is the first output value. For n is k is equal to 0 or n is equal to 0. Now again increment n value. So here the starting n value is 0. Now increment n value by 1. So what is n value? N is equal to 1, that is positive value. If n is equal to 1 positive value, I have to shift h of minus k to left side or right side? Right side. By how many indexes? By only one value or one index. Now if I shift this h of minus k to the right side, then I will get minus 1, 0 and 1. So same 1, 2, 1 is the sequence. Just the index value will be shifted and remaining amplitudes are same. So this is called h of 1 minus k, h of n minus k. Now to get the value at y of 1, that is n is equals to 1, then y of 1 is equal to, again multiply x of k with h of 1 minus k. Now if I identify the common slots, so here minus 1 value is 0. So 0 into 1, that is 0, plus at n is equal to 1, that is k is equal to 0, I have 1, here I have 2, 1 into 2, plus at 1 value I have 2, 2 into 1, that is 2. So 0 into 1, 1 into 2 and 2 into 1. So remaining values I have zeros. So therefore the common values, if I multiply and if I make a summation, I have 2 plus 2, that is 4. Y of 1 is equals to 4. So this is the second value I have, that is output value. Y of 1 is equals to 4. Again increment the n value by 1. So therefore I will get n is equals to 2. So at each and every step you have to increment the n value and get multiply with the shifted sequences. Now if n is equals to 2, then again I am drawing x of k value 1, 2, 1, minus 1. So this is x of k. Then h of 2 minus k. Now previously I have h of k is starting value is minus 1. Now again this value will be shifted to one more value to the right side. So therefore I have h of 2 minus k is 0, 1, 2. What is the sequence we have? 1, 2, 1 is the sequence. Now again multiply these two sequences in order to get the y of 2 value. So if you are taking a common slots, here k is equal to 0, 1, 2 is a common. So in this h of 2 minus k also we have 0, 1, 2 as a common. Then y of 2 is equal to, multiply the common factor, 1 into 1 plus 2 into 2 plus 1 into 1 plus minus 1 into 0. So here the value at 3 is equal to 0. Then 1 plus 4 plus 1, that is equals to 6. So 6 is the third value. Now how many values we have to consider? We have to consider the total length of the sequence is 6. 6 values we have considered. So first y of n is equal to, y of 0 already we have determined, then y of 1, then 2, y of 3, y of 4 and y of 5. So total 6 values we have to consider. Now again for n is equal to 3, then again we have to shift the sequence h of minus k. So if I shift the sequence, then I will get the value from 1 to 3. 1, 2, 1. Now again multiply this with this input. Then n is equal to 3, y of 3 is equal to, y of 3 is equal to, so if I multiply this with this, then first 1 into 0, 0, 2 into 1, that is 2, plus 1 into 2 plus minus 1 into 1, that is minus 1. Then 4 minus 1, that is equals to 3. 2 plus 2 minus 1, 3. Again if I shift the sequence, then h of 4 minus k. Again this value will be shifted by one more value. Then I have 0 at k is equal to 0, 0 at 1 is equal to 0. Now this sequence will have 2, 3, 4. Only 2, 3, 4 value with the shifted versions. 1, it is 2 and it is 1. So therefore y of 4 is equals to, again if I see the common slot is k is equal to 2 and k is equal to 3. So remaining values will be multiplied by zeros. So I have 1 into 1 minus 1 into 2 is equal to minus 1. So y of 4 is equal to minus 1 is the answer. Then the last, that is n is equal to 5. h of 5 minus k is equal to, again the same value will be shifted by one more sample to the right side. Then I have 2, 3, 4, 5. So again this value will be shifted to right side by one sample. So 1, 2, 1. Now y of 5 is equal to, so I have only one common slot, that is minus 1 into 1, that is minus 1. So these are the values of the output sequences. So therefore for the given input two sequences, x of n is 1 to 1 minus 1 and h of n is 1 to 1, then I have the output sequence y of n is equals to, So what is the first value we are getting? The very first value is 1, 4. Y of 0 value is 1. Y of 1 value is 4. Next, y of 2 value 6, 3, minus 1, minus 1. 6, 3, minus 1, minus 1. 6, 3, minus 1, minus 1. So therefore, the total length of the sequence is 6. If you are identifying the total length of the sequence is 6, then what about starting index value? That is, arrow mark should be at 1, because the starting index n value is equal to 0. So we have determined these two for the first pre-processing steps. Now this is how you have to calculate in terms of graphical representation. Now we will check the same using the sequence method. So in the sequence method, the first pre-processing steps, that is L value and starting index, that is common. So n value is n1 plus n2 and L value is n1 plus n2 minus 1. Now you have to write in sequence. So this is our sequence. Write in the vertical format, horizontal format as x of n and vertical format as h of n. So what is our x of n values? 1, 2, 1, minus 1. Then h of n value is 1, 2, 1. Now multiply each and every h of n value with each and every value at x of n. So multiply this row value of 1, 2 with all column values. Then 1, 2, 1, minus 1. Again multiply 2 with 1, 2, 1, 1. 2, 4, 2, minus 2. Then again multiply this 1 with 1, 2, 1, 1. 1, 2, 1, minus 1. Now you have to take diagonally. So take all diagonal values. So mistake will come while taking these diagonal elements. See, the first value will have only one value. Similarly, the last value will have only one value. Next I have two elements. Here also I have two elements. Then three elements and three elements. That should be matched. So therefore, y of n is equal to, now whatever the elements are there in the diagonal part, you just make a addition, summation. Okay. So first value is 1. In the second diagonal element 2 plus 2 I have. Third diagonal element 1 plus 4 plus 1. Next diagonal element 2 plus 2 minus 1. So next diagonal element 1 minus 2, then minus 1. So therefore, y of n is equals to 1, 4, 6, 4 minus 1, that is 3, minus 1, minus 1. See, whether I have considered the graphical representation or I have considered the sequence method, so I get the same answer. So then it is the starting index for n is equal to 0. So this is how you have to check your answer using the sequence method. As it is a short duration, we will use this short method to check the answer whether for graphical or tabular. So program, MATLAB program to write the linear convolution. So first write down the algorithm. First step is define x and define h. Define x and define h. Next one, find the n1 and n2. So here hint I am writing is, hint is length is a hint. So length is a command which directly find out how many samples we have in the given input sequences. Finding L. So what is L formula? N1 plus N2 minus 1. N1 plus N2 minus 1. Next, finding the convolution. Finding the convolution. So here we will use a command as first 4 letters of convolution. CONV. CONV. And display the output. Display the output. Next, plotting of first sequence X, plotting of H, as well as plotting of output sequence, that is Y. Plotting of X, H and Y in the same figure. So here we will use subplot. Next, based on algorithm, MATLAB program. So CLC, clear all, close all. CLC, clear all, close all. Then X is equal to, so here we are representing as variable. Input, enter the first sequence. H is equal to, again same, input, enter the second sequence H of n. Next, n1, finding n1 and n2, that is a step 2 in algorithm. So n1 is equal to, what is the command? Length of x. Now display n1. n2 is equal to, same command, length of h. Display n2. Next, finding the L value. So we have a formula for L. L is equal to n1 plus n2 minus 1. So display L. Next, after that we have to use a convolution command to find out the y. Y is equal to CONV of x comma h. Now display y. Then we have plotting session. So here y you can directly display, or else you can write down disp, that is display of the values of y of n are display y. Whether you can directly write down y, or you can directly first display the values of y of n r, then display y. Then we have only the last session, which is a plotting. The next one is plotting. So plotting of first input sequence x, then h and then y. Now to plot the sequences, first n1. So why I have given this different index as first x plotting, then y plotting, x plot, h plotting, then for y plotting. So first n1 is equal to, because first sequence is 0 to n1 minus 1. So in the first sequence we have 4. Then what about second sequence? We have only 3. So for that purpose n2 should be 0 to n2 minus 1. Now same in terms of y. Output sequence also again it will change, right? So output sequence we have given starting index is n. What is n value? 0 to l minus 1. Next, subplot 3, 1, 1. So first plot I am drawing about x value, that is x axis I have index, that is n1, and y axis I have x. Then grid on, the next label, y label and title. So x label discrete time because it is n value. Then y label is amplitude. Throughout these the y label is amplitude only. X label always discrete in time. Then title is first sequence. First sequence, if you want you can write generation. First sequence generation. Then similarly for plotting of h, subplot of 3, 1, 2. Next, stem of x axis is n2, y axis is h. So here also parallelly I am writing subplot of 3, 1, 3. So stem of x axis is n, y axis is y, output. Then grid on, x label, y label and title. X label is same discrete time, y label amplitude, title second sequence generation. Next, here also x label is same discrete time, y label amplitude, title. So what is title? Output sequence generation or linear convolution of two input sequences, or you can write down convolved output. Convolved output. It means after convolution. Next, grid off. So whenever you have grid on, it should be off at the end of the program. So while writing H, give it as a comment. Plot of y, here H plot, here input plot. Plotting of x, h and y. So instead of giving x, h, you can give x1 and x2 also.